Start. So far, we have seen the two models of diode. That is, ideal diode we studied. Ideal diode means once it is on, it acts as short circuit, and it is off, open circuit. On and off. Of course, ideal diode. And the second model is whenever the diode is on, it is represented by a voltage source kind of thing, V gamma, when it is on state, and when it is off, open circuit. Right here, it is like an ideal voltage source, I can write. But it is not a voltage source. The equivalent circuit looks like, right? It's a, right, not like independent or voltage source at all, right? It's not the generator. Once the power supply is given from the power supply, once it starts conducting, then we can write it ideal voltage source. It looks like, but it is not a voltage source. Looks like. Okay. And the third model, right? It is the first model. I have already told that, and it is the second model. We have done so many problems based on these two. Model 2. And third model, if you take so, that is the characteristics. First, if you observe so, V gamma, and here it is the slope which is given by 1 by RF. And what about the current voltage relation? Means the current is given by V minus V gamma by RF for V greater than or equal to V gamma is equal to 0 for V less than V gamma. And here, what is the equivalent circuit? Right? Means the equivalent circuit looks like, right, from this. Already we discussed all those things. From this, we can write V is equal to I into RF plus V gamma. Means the equivalent circuit of diode is something like this. V is the voltage across diode and I is the current flowing. So it is V gamma and this is RF. Like this. So V is equal to V gamma plus I into RF. That's the equivalent circuit, depending upon the data they give. Okay, now so far we have not done any problems based on this model 3. Let us do so. See this question. The VI characteristics of the diode in the circuit given below are I is equal to V minus 0.7 by 500 amperes for V greater than or equal to 0.7 volts and is 0 for V less than 0.7 volts. The current I in the circuit is, it is a question asked in instrumentation paper and electrical paper. Okay, how do we do this? From the given data, see, from this, what we can understand, I is equal to V minus V gamma by RF. So, definitely, this is V gamma and this is RF. So, V gamma is equal to 0.7 volts and RF is equal to 500 ohms or 0.5 K. Then let us replace the diode by means of its equivalent circuit. So, 10 volts, 1 kilo ohm, V gamma, it is 0.7 volts, RF, it is 0.5 K. Now it is like a simple regular network circuit. So what is the current flowing in this circuit? How do we write it? I is equal to 10 minus 0.7 by 1 kilo ohm plus 0.5 kilo ohm. And if you solve it, you will get 6.2 milliampere. It's a very, very simple thing. Okay, everything is fine. right? Some the given data we are doing it so. If that is just as an extension, okay, we have got the answer here 6.2 milliampere, everything is fine. But right, out of curiosity, what I did is I calculated the current through the what is the voltage across the diode. If I take voltage across diode, that is just nothing but V gamma plus I into RF. We are well aware of. V gamma is 0.7, I is 6.2 milliampere, and RF is 0.5 K. So milli and kilo cancel. I can write 1 by 2. It is 3.1 and zero point 0.7. So total 3.8 volts we are getting. It's not an appreciable value. Once the diode is in conduction, voltage across diode generally varies from zero point 0.5 to 0.5 to 0.8 volts. But overall, you are getting 3.8 volts. Why it is so means because of such larger value of RF. The diode forward resistance they gave as 500 ohms. Hardly it is 10 ohms, 20 ohms. Like that they might have taken. Okay, just out of curiosity only, I calculated it. They give the data, we did it. Right? That's where it is over. But not appreciable value. Suppose they gave RF is equal to 10 ohms, then what do we get? Right, I will do it in the next quiz. Suppose RF is 10 ohms, then V gamma is 0.7 volt, and here this resistor is 1 kilo ohm, 10 volts. So what about the current through the diode? And V is the voltage across the diode. I is equal to 10 minus 0.7 by 1010. Okay. So how much do we get? It comes around 9.21 milliampere or 9.2. Okay, nothing to worry. 9.2 I'm writing. So that what is V? It is V gamma plus I into RF. V gamma is 0.7 plus I is 9.2 milliampere into RF is 10. So how much we get? 0.792 or approximately 0.8 volts. Okay, 0.79. Why to write all those approximations? Okay, this looks as good value. Okay, so they have given 500 ohms, accordingly we did. Right, they asked us to find the current, but they have not cross-checked how much voltage it gives as far as the diode is concerned. Across the diode, it was giving around 3.2 volts, 3.8 volts. Okay, here current value is also changing. So of 6.2, it is 9.2 milliampere. At the same time, voltage is less. Okay, that's it. Just for our out of curiosity, I did so, but nothing to worry. If they take care of such things, right, it might be much better, because we always try to uh, bring something else from the problems that are asked in the previous grade papers. See this question. Consider the circuit shown in figure A. Okay, this one simple diode and resistor circuit. If the diode used here has the VI characteristic as in figure B, the output voltage waveform V output is if Vi is 2 sin omega t. What is the output if input is 2 sin omega t? Okay. From this given data, what we can understand, it is RF, and V gamma is equal to 0.5 volts. That's it. Then instead of diode, I can write its equivalent circuit. Zero 0.5 volts, RF is equal to 300 ohms. It is 600 ohms. We input. They are asking us to find V output. So V output is equal to Vi minus, what is the current in the circuit first? Vi minus 0.5 by 300 plus 600. That is multiplied with 600. Current multiplied with voltage. So what is V input? It is 2 sine omega t minus 1 by 2 by, it is 900 and it is 600. So 3 2s 3 3s 4 sine omega t minus 1 by 2 into 3 multiplied with. So it is 4 sine omega t minus 1 by 3. Or I can, strictly speaking, V output is 4 sine omega t minus 1 by 3. This is true if V input is greater than 0.5 volt. Condition. It's not true for all values because 4 sine omega t, if you take, it has positive and negative values. But voltage, the output voltage is always positive for all values of input. Means of course the diode output minimum is 0 and output maximum means 4 minus 1 by 2, that is 1 volt. We can take output has maximum amplitude of 1 volt, minimum amplitude of 0, it cannot take negative values. This is the idea here. Next, see this question. Find the diode current ID in the circuit shown below when the diode has cut-in voltage V gamma is equal to 0.7 volts and the forward resistance RF is equal to 45 volts. Okay, directly they gave V gamma and RF values. इसको कैसे सॉल्व करना है? हम सबको मालूम है इसका, right? Thevenin's equivalent we can write. What is its Thevenin's equivalent? V Thevenin's is equal to 10 into 100 by 100 plus 100. It is equal to 5 volts. And what about R Thevenin's? 100 ohms parallel with 100 ohms, that is 50 ohms. Then I am taking its Thevenin's equivalent circuit. 5 volts, 50 ohms. After that, instead of diode, I am writing V gamma in series with RF. 0.7 volts. RF is 25 ohms. This is 100 ohms. Okay. Then what about the current in the circuit? ID. Some network is given like this, and how do you find its current? Okay. ID is equal to here 5 minus 0.7 by 50 plus 25 plus 100, 175. 4.3 by 175, it gives us 24.5 milliampere. That's it. This is how we can find the current through the network. Or we can use the nodal analysis and all. Right? Anything you can do. If I assume this voltage as Vx by taking the node equation KCL at node X, we can find Vx. Once you know Vx, then ID is equal to Vx minus 0.7 by sorry 125. We can take it. Not required. Let us try to go with the easiest way. Next, say this. Calculate the current in the circuit shown below. Okay, how do we find the current? Through the diode. Okay, let me take this as Vs. Okay, then let us take the Thevenin's equivalent circuit for this. V Thevenin's is equal to Vs by 100 plus 100 into 100, that is Vs by 2. R Thevenin's, it is 100 parallel with 100, it is 50 ohms. Next, from the given data, we can understand that V gamma, it is equal to 0.5 volt. Then how do we find RF? It is delta V by delta I. Delta V, okay, means change in voltage. I can write 0.7 minus 0.5 right here. It is like, anyway, here it is looking like x2, x1 and y2, y1. Here with respect to this, y1 is 0. So reciprocal, right? Reciprocal of RF is the reciprocal of the slope, and it is equal to 4 milli minus 0. Okay. If I take it so, how much do we get? It is again equal to 0.50 ohms. Okay. RF we have got, V gamma is also known. Now let us take its Thevenin's equivalent circuit. Vs by 2, which is equal to, I will write it. Next, what we have here, diode. Diode is replaced by V gamma of 0.5 volt in series with RF, whose value is 50 ohms. R Thevenin's is also 50 ohms. Vs by 2, it is 2 plus sine omega t by 2. I can write it. Sine omega t plus 2. Okay, let it be. Now let me take this current as I. What is the current through the diode? Instead of diode, we are writing so. So what is the current through the diode? Or 1 by 2 sine omega t plus 1. We can write. Then I is equal to Vs by 2 minus V gamma, that is 0.5 by RTH 50 ohms plus RF 50. It is 1 by 2 sine omega t, or I can write here sine omega t plus 2 by 2 minus 1 by 2 by 100. It is 1 plus sine omega t by 200. I can multiply and divide with 5. So it is 5 into 1 plus sine omega t milliamperes. That's it. This much simple, we can do this problem. Okay, Thevenin's equivalent circuit, and instead of diode, we are writing its equivalent circuit. Okay, this is the idea. Okay, good. Now you can look at the options. 5 into 1 plus sine omega t milliamperes. Option B is correct. 50th problem. Anyway, here no data is given. We did it so. Okay. So it is 5 into 1 plus sine omega t milliampere. Next. See this question. The piecewise linear VI characteristics of a diode is shown in figure. Okay. When the applied voltage is 6 volts, the current through the diode will be. It is also one interesting question. Some characteristics are given and they are saying that what is the current corresponding to 6 volts. Okay. How do we do this? See, here they have not mentioned anything. Don't think that it is 0. It is not 0. We do not know what it is. Okay. So it is like, right, actually what they did is the characteristics of diode are something like this, and they took some points, maybe somewhere here it is 2 volts corresponding to 14 milliampere, and with respect to 4 volts it is 34 milliamperes, and if it is 6 volts, what is the corresponding current? Actually this is what they are asking, I and B. Instead of show, if they show like this, just like that you will understand. Instead of showing so, they showed this one, and of course they did not mention anything. What is this? Okay, so with respect to, let me take this point as x1 y1 and this point as x2 y2 and this point as x3 y3. Okay, x1 y1 means 2 volts comma 4 milliampere, x2 y2 4 volts comma 34 milliampere, and x3 y3 6 volts comma how much? That's what we need to find. Okay, so how do we do this problem? So we know that the straight line equation y minus y1 is equal to m into x minus x1. So instead of y, what I have? I minus y1, it is current is 14 milliampere, is equal to slope m. M is equal to y2 minus y1 by x2 minus x1. y2, it is 34 milli minus y1 14 milli by milliamperes, of course. It is 4 minus 2. So 20 by 2, it is 10. We can write 10 into 10 power minus 3 slope. Millimos, of course. 1 by resistance, or 100 ohms. In terms of R means it is reciprocal of it. Okay, 100 ohms is the slope of this line. R implies RF is equal to 1 by slope 100 ohms. Okay, let it be. Now slope here m is equal to 10 power minus 2, even I can write x minus x1. X is V, x1 it is 2, V minus 2 we can take. Okay, this is how we can take it. We have got the straight line equation, or I is equal to, well, that much is also not required. Okay, so now what they are asking, or I can write here 10 power minus 2 V minus 2 into 10 power minus 2 plus 14 into 10 power minus 3. Okay, we can write it so. So if voltage is equal to 6 volts, what is the current? If V is equal to 6 volts, then I is equal to 6 into 10 power minus 2 minus 2 into 10 power minus 2 plus 14 into 10 power minus 3. 6 plus 2, 6 minus 2, 4. 4 into 10 power minus 2 plus 14 into 10 power minus 3. 4 into 10 power minus 2 can be written like 40 into 10 power minus 3 plus 14 into 10 power minus 3. Ultimately, what we get? 54 milliamperes. That's it. Okay, this is the idea behind it. What is the straight line equation? Once you know the straight line equation, then right from this equation, for each current, each voltage, what is the current? Voltage is 2 volts. What is the current? Voltage is 4 volts. The corresponding current, voltage is 6 volts. What might be the corresponding current? We can do this.